Kaliro TV.
Good afternoon, ladies and gentlemen who are viewing us at this time. My name is Mpambire Yoweri. I told you I'm a teacher of physics, and I'm right away to continue up with the lesson 2 as I promised before. Lesson for today, as you're seeing on our board, the second lesson 2 to the third Jan, displacement and acceleration, is what we are going to look at today. And right away we shall start on by knowing the definitions of the major terms of our topics today, And I told you we are going to be going through lesson by lesson. So lesson 1 we looked at very many things, and then today we are going to look at displacement and acceleration. We shall start with the displacement. What is the meaning of the word displacement? You know, you have been hearing us talk about displacement, but you may be asking yourself, what is displacement? Now, in your learner's book, they are saying, select a student and instruct him or her to mark a point in front of the classroom, and then moves 5 steps to the left and then 5 steps to the right. What does it mean? What is left and then right? Left and right means direction. We are trying to show you direction. So when you move to the left and then you move to the right, what are you not seeing? Aren't you making some movement? That is what we call displacement. You are moving a certain distance, but to the left. Okay? So moving to the left means that you are moving a distance in a specified direction. And in actual sense, displacement in simple terms means the distance moved by a body in a specified direction. So we may also ask ourselves, what is the meaning of the term distance? Distance, simply, but when you check into your notes, you can know the distance is the length between two given points. When you move from one point to another, that is what we call a distance. Now, we are also going to check up with the velocity, because velocity is also connected to acceleration, and we are supposed to be knowing such. So velocity is a connection to displacement. So in simple terms, we are supposed to know what is velocity. Velocity is the rate of change of displacement. When you change displacement with the time intervals, equal time intervals, you are doing what we call, you are moving with a velocity. And there is a relationship between velocity and the speed. But speed is the rate of change of distance, not displacement. Remember, displacement, you have a specified direction. Then what are we supposed to know else there? We are supposed to know about uniform velocity, the constant rate of change of displacement. Then we are also supposed to know about what we call acceleration. And acceleration is just in simple terms the rate of change of velocity. Rate of change of velocity. The velocity changing with the time is what we call acceleration. And now in our learner's book, our next part or topic is to see how we can measure acceleration by measuring it using one of the most known instruments which we use in the laboratory, and we are going to see just that right now. I've told you that we are going to look at one of the instruments which we use to measure acceleration, and what we have selected is our usual instrument which we always use in our laboratory, and it is called a ticker tape timer. So this instrument is going to help us, we are saying, measurement of acceleration using a ticker tape. But acceleration is not the only physical quantity which is measured using a ticker tape. A ticker tape measures even some other quantities like displacement and then velocity. So we are going to be learning how to use a ticker tape. What you are seeing on your screen is what we are calling a ticker timer, and that's its diagram. And we're saying a ticker timer is a device used in a physics laboratory to to study speed, velocity, and acceleration of the body. So it consists of a vibrating arm which vibrates due to changing alternating current applied to it. I told you alternating current is a type of current which flows in two directions. It is the opposite of direct current, because direct current is a type of current which flows only in one direction, and we are seeing all the parts: the vibrating arm, the carbon disc, we have the ticker tape, then we have alternating current, the solenoid, and then we are supposed to know that acceleration and velocity of the body can be determined by using a ticker tape timer. A ticker tape timer consists of a steel strip and a hammer which prints dots on a tape being pulled by a moving body. So are you seeing this kind of tape? Let me try to put it up. So I'm trying to ask, are you seeing this tape? This tape is connected to a moving body, and as it keeps on moving, the moving body keeps on stressing it. When it keeps on stressing, the steel rod or the carbon disc and the hammer, they keep on putting on some printing on dots on the tape as it is being pulled. So using a ticker tape timer, a longer tape is attached to an object that is moving. The tape is threaded through the device that puts the dot on a tape at regular intervals. This leaves a line of dots on the tape that is recording the motion of the body of the object. When connected to AC supply, the timer keeps on putting on dots, but the dots which are put there depend on the frequency of the AC supply. For example, if the AC supply is 50 Hz of frequency, the ticker tape timer prints 50 dots in 1 second on a tape at equal intervals. So we are going to see those dots, these ones. Now there is a distance between these two dots. The two dots, there is a distance. So the time taken for a dot to the printer to print a dot from this dot to this dot, that one is called a tick, one tick. Now this one is uniform. When you take this distance from here to here, it is uniform, even here. But as you go here, we keep on seeing again there is a non-uniformity. So the non-uniformity also causes a change in something. The actual speed of an object at a particular time can be determined by measuring the distance and the time between two successive dots. Changing length between two successive dots on the tape indicates that the velocity of the body is changing. That means the velocity is not uniform. We are right away now going to know how to determine what we call acceleration and how to determine what we call velocity. But acceleration itself is equivalent to velocity divided by the time, and then velocity is distance divided by the time. But this distance here changes from distance to displacement. Why? Displacement, distance moved in a specified direction. So sometimes it is similar to velocity, is similar to speed. That's why you're seeing me have put here the term distance here. But in actual sense, whenever you are dealing with velocity, you are supposed to think of displacement there. So right away, we are going to also look at something here very small. We are saying that for a ticker timer, time taken between successive dots is called a tick and is given by 1 tick equals 1 over the frequency. You get the second. Now, what are we supposed to know with that? Okay, that one is called the period. It is called the what? The period. As you remember, we said period is the time taken to complete one complete cycle, but here we are saying period is the time taken to print any two successive dots on the tape, and it is measured in seconds. Okay, so we are supposed to also be knowing that as I move my camera near here and you happen to see what I'm talking about. So we are calling that 1 tick, and it is equivalent to period, which is capital T. Capital T, which is the period, and it is going to be equal to 1 out of f. What is f? F is the frequency. F is the frequency. And as I try to show you here something here, without to now come and know, this is the number of dots printed per second. The number of dots printed per second is what we are calling frequency, and it is always given in our question. So we are going to start by calculating velocity. Then after calculating velocity, we now go to calculating acceleration, because acceleration is equal to a formula which is written here. Acceleration equals to v minus u divided by t. V meaning final velocity, initial velocity, then time taken. So you cannot calculate acceleration when you don't have velocity. As I told you, we are now going to calculate velocity first, then we calculate acceleration, then we come to know how this can be done. Remember, we have even some other activities which we shall do practically in our laboratory when we go back to our schools, but for now we can be doing this and then we know. So we shall have these activities: investigating the motion of a trolley on a horizontal way. We shall use our ticker tape timer, and then we shall even have investigating the motion of a trolley on a tilted runaway. We shall also look at them and we see what is the difference. We shall do that practically in our classrooms as we go back. So I want to show you something here. And we are saying calculate. We are saying first note the distance between the reference dots. What are we meaning by the reference dots? The reference dots are these ones. For example, this is the reference dot and this is also the reference dot there for that question. Then find the period from t equals to 1 over f. Period is the one we called 1 tick. 1 tick is the period, and the distance and the time taken between two successive dots is what we are calling the period, and it is called 1 tick. So it is going to be 1 out of f. Then find the time taken to print the reference dots. This one is got by time taken equaling to period, which is 1 over f times the number of spaces between the reference dots. Then after that, we now come and see. Then we get the speed or velocity is got from distance covered divided by the time taken. Let us look at the example. The figure below is a tape which pulled through a ticker timer of frequency 50 Hz. They are telling us calculate. Let us calculate the period. They're telling us to calculate the period, and then afterwards we calculate the time taken to print the reference dots, then the time taken, the speed at which the tape is pulled through a ticker time of frequency 50 Hz. They have given us the diagram as I showed you in the video, and they are telling us find the period, and then find the time taken to print the reference dots, then the speed at which this one will run. 0.02, and this one is in seconds. So that one is the period which they wanted us to come up with. Now, Roman 2, we are saying they said they wanted now the time taken for the ticker tape to make the reference what? Dots. So time taken equals to the period times the number of spaces between the reference what? Dots. They wanted even the time taken for the ticker tape to make the reference dots, and then we are saying that the time for the period is 0.02, and then the time taken, we get the period times the number of spaces. So this is 0.02 times 6, and then it becomes 0.1 2, that is time taken in seconds. Now, how do you find the velocity? The velocity is just found by looking at the distance between the reference dots and then divided by the time taken. And that's why we are saying that this is 12 and then divided by the time taken, which is 0.12, giving us 100 meters per second. And that is the velocity which that kind of body took, or it was moving with. So now, that has been our presentation for today. I remain in Pambido Yowen, who has been the teacher or the facilitator for this kind of presentation today. And I'm very sure that tomorrow we shall begin with how to calculate calculation, how to calculate calculations on acceleration using a ticker tape timer. Thank you for viewing us, but don't forget to subscribe on our YouTube channel in case you happen to reach the YouTube channel. Just press that button which has subscribe, and then you subscribe, and then you stay tuned such that whatever we are posting, you keep on seeing it. Thank you very much. I wish you a nice time.